Hello YouTube, De-bodgery here. Welcome to EV Components Review. A friend of mine, James, he sent me a bunch of pictures of his Spintend 85-150 controller so that I could make a teardown based from photographs. Anyway, it's all I've got right now to be able to do teardowns on. Without any camera equipment and things like that, and no equipment, I can't really do anything else. So anyway, thank you, James, for the content to be able to make a video from. Spintend is kind of in the same price range and quality range as FlipSky, but I'm going to just say right up front, Spintend is better than FlipSky. FlipSky diverges from VESC standards, and Spintend does not. And as I do this video, you'll see how that plays out. And also, Spintend adds some other value adds to these controllers that you don't typically get from a FlipSky. So yeah, I would have to say Spintend is definitely a step above FlipSky. If you were to ask me which would you rather have, I will tell you Spintend every day of the year, just because they really are a smidge better. And I've known that from the first moment I ever saw Spintend that they were a little bit better than FlipSky. Yeah, it just as I get through here, you'll see why I say that. All right, so let's move on to the logic board. All right, so that's this guy right here. I'll make that a little bit bigger. See a little closer. All right, so the first thing I want to talk about is all these connectors right here. This is something that a lot of people will struggle to find if they ever want to make them themselves, make those cables themselves. For whatever reason, you lose yours, you pull the wires out, something like that. So this is called GH, as in like Gary Hall. Um, GH 1.25. The 1.25 indicates the pin spacing, i.e., the distance from here to here or here to here is 1.25 millimeters. So these pins, each one of those pins are really tiny. They're very, very, very small. So if you do want to make your cable, make a replacement cable for whatever reason, you're going to probably be using like say 28 AUG wire, and the pins themselves are extremely tiny. I have had this entire kit to be able to crimp all those cables and things for all those different pin counts and more. And I know exactly how small this stuff is. It can be done, but if you're any kind of a gorilla, well, expect to have a frustration level because this is little tiny delicate stuff. These pins are really really small, so that's probably not something for everybody. But yeah, if you're careful and things like that, you can definitely crimp these pins. I don't consider myself to be anything other than a klutz, and if I can crimp them, then probably most everybody else can too. All right, so I definitely like seeing a USB-C connector. A lot of controllers will have a mini or rather micro USB connector on them, and I don't honestly know why that is, but yeah, I've seen that far too often. A lot of FlipSky stuff has still got micros on it. So USB-C is definitely an improvement there. Why people aren't using USB-C for everything nowadays is just beyond me. All right, so one of the ways that this is improvement over your typical FlipSky stuff is some value add. So right here, you have an external 12 volt DC to DC converter. Um, it's got a couple of MOSFETs on here for, I believe, for switching this thing on and off, and also a current sense shunt on here. There is 4 ceramic caps for filtering, battery bus into this board, and there's also 4 ceramic caps for filtering the 12 volts out. So all of this is completely independent of onboard stuff, other than maybe like turning it on and off, which you would do from like say VESC tool. Um, but yeah, none of this right here powers onboard things in any way. It's purely external use. And so this DC to DC goes over to this 12 volt connector and also over to this fan connector. Right here, these two JL parts, those are fuses. So this one right here, you can see the circuit trace goes over to those 2 pins, and that's the 12 volt side, and those 2 are the ground pins right there. So that's a little surface mount fuse. I don't know its rating. I don't know what JL stands for. I'd have to go look it up. But anyway, yeah, there's a little fuse to protect this connector from getting overloaded. It's surface mounted, which means you can't just plug in a replacement. You'd have to solder one in place. But I don't personally think it's very hard, but other people might. This second fuse right here goes in line to this little MOSFET right there, which then switches on and off 12 volts to this connector over here. So that fan can be turned on and off. Exactly how that's done through Vestool, I don't know, but obviously there's some functionality in Vestool that lets you do that. Turn the whole thing off, turn off just the fan connector, things like that. That's all in there. Don't know exactly how that works. Anyway, this is a nice little value add, a little onboard 12 volt DC to DC that's completely independent of everything else. It has to get some kind of a control signal from the CPU. This is an STM32F405, so there's going to be at least an enable signal that comes from here over to this chip, but that's about it. I don't even know that this thing reports current to the STM32. Maybe it does. So maybe that happens as well. But yeah, I would bet that control from over here to this DC to DC and this little MOSFET is probably pretty minimal. But still, it's nice that this extra stuff is on here. All right, so this little section right through here is all of your power for onboard. This is all 12 volts for external. So this right here is your main inductor for, and that's a control chip for the 12 volt DC to DC converter that brings battery voltage down to 12 volts for running the gate driver chips, which are over here. And then this right here is a 5-volt linear regulator. And that's going to run like these 3 chips here, which I'll talk about in a minute. And then right there is your 3.3-volt linear regulator for powering the CPU. Since the power requirements for this stuff is fairly low, these are probably sufficient for the job because all they're doing is powering onboard stuff. All right, so these 3 little chips right here, this is something that is flat out lacking on anything from FlipSky that I've ever seen. And what they are is current sense amplifiers. And in fact, if you look on the FlipSky website, any place that you can buy FlipSky stuff, they all tell you to turn off whatever they call it, current sense monitoring or something like that. Somebody else can tell me what it is. It's been a while since I messed with the FlipSky to remember what that setting is. But yeah, I think it's on the FOC tab. There is a drop-down menu where you can pick one of 3 options, of which one of them is disable current sense detection or something like that. Anyway, yeah, you have to turn that off on FlipSky. And the reason why is because these 3 little very inexpensive parts are missing. Yeah, that's the physical reason for it. Anyway, and here it is. Spintend has them because Spintend does meet the minimum specifications for VESC, and FlipSky does not. And they never have. They've always tried to cheapen things out further any way they could, get away with things that they could get away with. And well, Spintend doesn't go that low. I mean, it's still a really cheap controller, but they're not going to break the VESC standard. So one of the things about FlipSky is they are not allowed to use VESC in their naming. And that's because Benjamin and Frank won't let them. Whereas probably Spintend doesn't have that problem. And it's because of things like this. They're actually meeting the minimum requirements for VESC, and FlipSky is not. All right, so I've got a couple close-up pictures that are of reasonable decency, which is the bottom of the board. So on here, you can see how the connectors will work. Let me range this a little bit. There we go. So I don't know which side of this board, or whether this connector or this connector is battery plus and battery minus. So I can't really say to that. All on the bottom of the board here, this is all of a ground plane. I'm glad that it's there, but keep in mind Spintend is still cheap. It's still the bottom of the barrel that you can get without like removing VESC standard functionality. Um, if they would have used a 3-layer board rather than a 2-layer board, in other words, 3 layers of copper, they could have made the whole entire bottom side of the logic board a solid sheet of copper, and then taken all this little circuitry and put it on the inside middle layer. As is, because you don't have that. You've got circuit traces here that are acting like antennas, and they're picking up noise off of the power stage. So this logic board could be a lot quieter if you had a solid ground plane across the bottom of here with no little circuit traces in it. But this is better than nothing. It would have cost them, $1 more or whatever per board, probably not even that much, to have a 3-layer board rather than a 2-layer board. And then they could have put all these little circuit traces inside rather than on the bottom. and that would have made for a quieter power stage because it would have been much more immune to noise coming off the power stage. Anyway, we'll pretend like that's the battery plus connector, and that's probably all that comes out of there is battery plus, and then that would be the battery minus connector, and all that comes out of there is battery minus. And then that would be a low side connector if that was the case, of which two of those pins would be for the shunt. One of them would be for uh, the uh, the gate control, and the other ones probably be like connect to battery minus. And then up here would be the same thing. You know, so two of these pins would be for the uh, or maybe the way this works is one of these pins is for the thermistor, another pin over here is for thermistor, and then one of these is for battery plus, and two of them are for gate drive, something along those lines. Anyway, so yeah, you're going to have that duplicated across all of those three, and then that'd be like battery plus, and that'd be battery minus. All right. Um, so a little bit better picture of the DC to DC section. So here's your external DC to DC. Here's your 12 volt DC to DC right there. Here's that 5 volt linear regulator, and here's that 3.3 volt linear regulator. Here's that little MOSFET for turning this fan off and on. Yeah, you can see the little circuit trace going right over there to the fan leg. You can see how that fuse, that JL fuse, goes right to those two pins. This one here is kind of buried underneath here, but it goes over to there. You get some through holes that go down to that MOSFET or somehow or another that works to turn that little bugger back on and off. This is probably some kind of a driver chip for that MOSFET is my guess. Don't really know. Anyway, that's pretty much all I'm going to show you there. Yeah, without doing a proper macro video, I'm not going to show you much more. All right, so here is your 3 gate drive circuit. So the EG3112, I believe that is the exact same part that is used on the FlipSky controllers. A lot of your Chinese stuff uses these things. They're very basic, very cheap gate drive chips, and not particularly good. They're not isolated, anything like that. They're fairly noisy. They have no controls in them, anything like that. No firmware, not programmable in any way. Just very, very basic, on-off gate drive chips, and that's about it. Anyway, yeah, this is Spintend. They're not really looking to build a high-end controller. They're just looking to build something as cheap as possible and still meet the minimum requirements for VESC, and so they do. This is a little disconcerting. So you see these little plastic pads on here, and I believe there's another one over there as well. Actually, let's just go back to the other picture. Yeah, there is. There's one more over there. So those little plastic pads, they push down on the inside of the top cover to push this board onto the header connectors to keep the logic board in place over the power stage. I would much prefer to see screws, but there are no brass standoffs that hold this board down to the power stage. It's all done by pressing the lid down onto these little plastic standoffs to hold it in place. And as you can see, they've all got like a little bit of silicone to stick it down to the board in the appropriate places. Yeah. But, hey, this is Spintend. It's not exactly high grade stuff. It's still pretty damn cheap. VESC. If you ask me, would I rather have Spintend versus FlipSky, I will flat out tell you yes, because this is still a step above FlipSky. It's the minimum requirements for VESC. It really is. Yeah, and don't expect any bells and whistles that are going to just be really good. Expect it to be still, very cheaply made as much as they possibly can. All right, so let's look at the power stage. Okay, so yep. Again, very basic power stage, just a step above, just slightly better than FlipSky. At least it has ceramic caps on it, so all three of them, woohoo! Whereas like everything I've seen from FlipSky has none at all. So yeah, that's a slight bit better than FlipSky. At least it's got them. But it doesn't really have enough. But keep in mind this is Spintend. They are only slightly better than FlipSky, and they're still trying to make it as cheaply as possible. What they really should have done is put at least another 3 ceramic caps over here. And really, since it's much further away from where the battery wires are, I would say 6. And then they really should have like 3 in here and 3 in here as well. Yeah, so being that the electrolytic capacitors and the ceramic caps are over here, they are doing absolutely no good whatsoever for those MOSFETs right there, and only marginally something for these ones. and they're doing a decent job for those two. So I bet you anything that if you look in monitoring in Vest Tool for the three phases, you'll see that this phase is quite a bit noisier than this phase is, and you'll be able to see that, uh, because of where the capacitors are. You're just going to be able to visibly see much more noise on that phase than you do on the first phase closest to the caps. Um, this is typical low side shunt stuff. So yeah, here's battery minus obviously, and you got three shunts across there, three shunts, three shunts. So typical, VEST standard stuff for low side shunts. Nothing really special about that. They could have tightened this up a little bit. So you can see this little gap in here between the shunts and the battery minus bus. They could have had these shunts actually touch and then solder them there so that you don't have this little current hotspot in here. And the same thing up here. I'll bring this up just a bit closer to get the top side of the shunts to the MOSFET legs and close up that gap and close up that gap too. And that would optimize those current paths just a smidge. Um, Also, this is unbalanced. So here is the battery minus wire. And I believe this is a piece of copper, not brass like FlipSky uses. And it's a single continuous piece, so good for you, Spintend. FlipSky uses whatever pieces they have. Um, so the battery wire comes in right here. So inductance right here is very low, and inductance over here is much higher, in the battery bus. Whereas if they would have just soldered the battery wires right here in the middle, then inductance either direction would be the same. So again, this phase over here is going to suffer from a lot more noise from inductive losses and being farthest away from the capacitors than, say, will this phase. So yeah, it's an unbalanced design, and that one would have been a no-cost change. Just simply where you solder the battery plus and minus wires down would have fixed that one. Really needs ceramic caps over here. Really does. Okay, so being that this is VESC, and they don't miss the standards, you can see three thermistors on here, like you should have. So yeah, again, that's VESC standard, and that's something that I'm pretty sure Spintend, or I'm sorry, FlipSky uses just one thermistor, not three. It's another way they can cut some cost out of things, and of course diverge away from VESC standards. And standardized VESC is a current I'm sorry, a temp sensor per phase. So you've got all three of them like you should. Uh, you'll notice you've got a little, that's probably a TVS diode, I'm guessing, resistor and a capacitor, and that's for each one of the gate drives. So that's going to go to the gate leg of each one of these tall MOSFETs, and you've got the same thing up here on the high side as well. So most likely two of these pins are for gate drive. You can see this little circuit trace going up to here, so probably that pin right there is going to this thermistor, and then you can see that circuit trace going down here, probably like to that pin or something, and that's the other side of that thermistor. So each one of the thermistors has got two legs going up to the logic board, which it should. So that's all good too. You can see that the board is screwed down in several places. Two screws here. You can't see them here, but you can see that one up there. There's plenty of screws holding the metal core printed circuit board down to the shell so that you have decent heats transfer from one to the other. But you can also see that there's no standoffs here. You could easily have put brass standoffs in those holes right there so that you could put screws in those to hold the logic board down to this. And well, you don't. You just got those little plastic pads that go through the lid to hold the logic board down. So that part's kind of a meh. Definitely would have preferred brass standoffs instead, but whatever. Uh, this is still, very cheaply made. It is. Spintend is. You'll never hear me say that Spintend blows me away with its quality because it doesn't. But it is better than FlipSky. Yep. All the parts that you're supposed to have here are here to meet VEST standards. They're just done to the minimal level that you can. Probably because this at least has three ceramic caps, this is probably a little bit quieter than a FlipSky power stage, which you would be able to see on the monitoring tab in VEST tool. But is it going to just be epically quieter? No, not likely. It's just going to be a little bit better than FlipSky. But yeah, at least a little bit better is better than not better. You can see that the three capacitors here are 100 volt, 330 microfarad. I don't know anything about this NHA brand, something Chinese, I'm sure. If I go back to the other picture, yeah, you can see there's a space here and a space up there. pretty darn sure they could have fit another electrolytic capacitor across that space. Yeah. More is better in this regard, definitely is. And 3 is probably just barely making this thing work, or just enough to make it work. I'm really curious to see how hot those capacitors get. They might get quite warm, or they might not get warm at all. I honestly don't know. How warm the capacitors get tell you just how noisy this phase bus is, or this whole power stage is. Because if they're having to work really hard, they're going to get hot, and if they're not getting warm at all, then they're not working hardly at all. And I don't know which it is. Anyway, let's move on to the next picture. Just another view of the power stage. You can kind of see it right there. In fact, I can probably bring that in a lot. Yeah, there we go. So you can see right there, it says 1001 on there. And I believe these are Hawaii, or I don't know. There's almost a logo I can see right there on that. This is the best picture I have of the MOSFETs. But whatever they are, I believe the 1001 is a 100 volt, 300 amp or 290 amp MOSFET, in which case 150 amps is going to be well within the operating uh, current range for these MOSFETs. If you look at this solder, it's very shiny and glossy. This and not grayish looking, not dull. This is a decent grade of lead-free solder. Yeah, if the solder was very dull gray looking, I would say they use the absolute dregs of cheap lead-free solder. And being that it's glossy, they use something that's of a decent grade. So good for you on that one. Spintend, that's something that you'll see on the flip skies. The solder is very gray looking, very dull looking, and it's because it's just how cheap the solder is. Another corner you can cut, right? It's still solder, but it's even worse, low grade stuff. So anyway, yeah, glossiness tells me that it's not the super cheap stuff. Anyway, I think that's everything I want to show you about this controller. Just go back over that again real quick. Yeah, you have all the parts. You've got your current sense amps. No corners cut as far as pulling parts away that you should have. Not super fond of these little plastic pads for holding the logic board down to the power stage. Really prefer to see those screwed down instead. Kind of nice having this little value add on here, a little 12 volt DC to DC that's added. Yeah, I like seeing ceramic caps on the power stage. Um, got at least 3 of them. Wish it had more, but I'll take it. That's more than what Flip's guys got, which is 0 for stuff in the same power range. So yeah, it's a decently built thing. It's interesting. You see, it says 100 volt, 100 amp, and yet it says on the shell that it's the dash 150A. So I'm guessing that this power stage, it must be used in the 100 amp stuff as well. Huh. Anyway, better than Flip Sky. Definitely better than Flip Sky, but still not epically better. Anyway, folks, I hope that helps you out in making some decisions. Again, if you ask me which would I rather have, Flip Sky or Spintend, definitely Spintend. It has all the stuff in it that it should have to meet best standards, and Flip Sky does not. Still, super cheap.